mentioned in the previous video, the other way to solve systems of equations is when they're both in standard form, you can use the elimination method. So standard form, as a reminder, is when both variables are on the same side with your constant on the other. And standard form is represented as ax plus by equals c, where a, b, and c are your coefficients and c is your constant. C will always be your constant whenever we are talking about any type of function. Alright, so to get started, remember you have to first identify a zero pair. You have to determine if when adding your equations you have a zero pair. I'm looking at both of these equations right here, and right now I don't have a zero pair. I'm really close. Y plus y is 2y, but y plus negative y cancels out. So I'm going to distribute a negative 1 to this bottom function, which is going to give me a negative y here and a positive y up here that will eventually cancel out. So negative 1 times negative 3x is positive 3x. Negative 1 times y is negative 1y. Negative 1 times negative 5 is positive 5. Then I'm just going to rewrite my top equation without doing anything to it. Once you have a zero pair, you can cross it out and add straight down. So 3x plus 8x is 11x. 5 plus negative 11 is 5 plus negative 16 is negative 11. Divide by 11 on both sides and you get x equals negative 1. That's only half of your answer. So at this point you could cross out any multiple choice options where x was not equal to negative 1. But now we have to solve for y. So you can pick either one of your original equations or your new equation after you multiply it. I'm just going to pick this top equation. So I have 8 times x, which we said was negative 1, plus y equals negative 16. I took the x value that I just solved for and substituted it in for the x in the original equation. So I plugged it in or substituted it everywhere I had an x in that top equation. Now what I need to do is solve for y. So 8 times negative 1 is negative 8 plus y equals negative 16. I'm going to add 8 to both sides using the addition property of equality. Y equals negative 8. So to write my final answer, I would write negative 1 comma negative 8. So if you were to graph both of these lines, they would cross at the point negative 1, negative 8. Alright, number 6 is very similar. So I'm looking at our top equation, negative 4x plus 9y equals 9, and x minus 3y equals negative 6. Looking at here, negative 4x plus x does not give me 0, 9y plus negative 3y does not give me 0, so I need to find a zero pair. I'm going to multiply my bottom equation by 3, that'll again cancel out my y. By multiplying this by 3, I'm going to get negative 9y here, and I have a positive 9y up here. If you can't find a zero pair, the easiest way to do it is just to multiply your crisscross your coefficients. So multiply this top one by 1 and the bottom one by 4 or negative 4, and that will cancel it out. So if you can't quickly identify one, just crisscross your coefficients and that works every time. So I'm just going to rewrite this top one, and then I'm going to distribute this 3, so 3x minus 9y equals negative 18. I multiplied the 3 by everything in the equation, including the constant at the end. Now I'm going to add straight down. Negative 4x plus 3x is negative 1x. 9y plus negative 9y cancels out, equals negative 9. Divide by negative 1, x equals 9. Now, same thing like we did over here, we need to plug in 9 for x to solve for y. So I'm going to plug it into this equation right here, the x minus 3y equals negative 6. So I get 9 minus 3y equals negative 6. I substituted this 9 for this x right here. Subtract 9 from both sides, and I get negative 3y equals negative 15. Divide by negative 3. Y equals 5. So my final answer would be 9, 5. The most common way that they test for systems of equations on the EOC is going to be given a word problem. So when you have a word problem, you have to create two equations and then use elimination or graphing to solve for their intersection. So number 7 says that the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. So 3 senior citizen tickets, 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. So the first thing we need to do is to identify and label our variables. So we have senior citizen tickets, child tickets, and dollars. It does say a total of $38, so I know my equation is going to be equal to 38. I am going to use X for senior citizen and Y for child. And I always like to make a key for myself, and I also like to use X and Y because S can sometimes look like a 5, which gets a little bit confusing, and X and Y are just very easy, and we've been using them quite a bit this year. So for my first equation, I have 3 senior citizen tickets. So I have 3X plus 1 child ticket, so 1Y, made them $38. On the second day, they sold 3 senior citizen tickets again, so 3X plus 2 child tickets, and they made $52. And they want us to solve this equation. So I do not have a zero pair right now, but I can create one by multiplying one of my equations by -1. So I'm going to multiply this one, -3x minus 1y equals -38, and then I'm going to add straight down. Ignore this line in the middle, I didn't mean to do that. So 3x and -3x cancels out. 2y and -1y is 1y, and then you would do 52 plus -38 to get 14. What that means, and then divide by 1, y equals 14, and now I have to solve for x. So I'm going to plug it into this equation here. I get 3x plus 1 times 14 equals 38. 3x plus 14 equals 38. 1 times 14 is 14, so I just simplified that right here. Subtract 14 from both sides. Whenever you do the same thing to both sides, that's a property of equality. So this would be the subtraction property of equality. You get 3x equals 24. Divide by 3, and x equals 8. So what we could say is a senior citizen ticket, or a senior ticket costs $8, and child ticket costs $14. Alright, we're going to do the very same thing for number 8. This time it says the senior class at High School A and High School B planned separate trips to New York City. The senior class of High School A rented and filled 1 van and 6 buses with 372 students. High School B rented and filled 4 vans and 12 buses with 780 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? Okay, so it says High School A rented and filled 1 van and 6 buses with 372 students. So 1 van plus 6 buses is 372 students. High School B filled 4 vans and 12 buses with 780 students. So 4 vans plus 12 buses is 780 students. So now I have to see if I have a zero pair. I don't, so I'm going to multiply my top equation by -4. That's going to cancel out this +4 right here. So I get -4v minus 24b equals -4 times 372 -1,488. So I distributed this -4. Now I'm going to add straight down. My v's cancel out. 12b plus -24b is -12b equals 780 plus -1488 negative 708. Divide both sides by negative 12. So negative 708 divided by negative 12, 59. So the buses carry 59 students. So now we have to see how many the vans carry. I'm going to plug in or substitute this b equals 59 for a b in my original problem, and I get 1v plus 6 times 59 equals 372. 6 times 59 is 354. So 1v plus 354 equals 372. Subtract 354. So 3. I get 18, so I get 1v equals 18. So every van holds 18 students. So buses, 59 students. Van, 18 students. And that would be my final answer. It's very important that if this were a constructed response question that you include your units. So don't just put x equals 59, y equals 18. Interpret it in context of the problem. So the bus had 59 students. The van had 18 students. That would receive full credit on the EOC.